Okay, so this video is just a short introduction to the propagation of error and how error works through calculations. I think it's important that you understand this more so than just try to learn off formulas. So the first thing we want to look at is just basic addition, okay? So let's say, for example, we've got an object A, and it has been measured to have a length, an average length of 25.3 centimeters. And we know that we've got a certain amount of error, and that's plus or minus 0.5 centimeters. So what happens now if I'm now going to add two of these? So I'm going to just label them A1 and A2. So I have 25.3 centimeters and 25.3 centimeters on the first one's 25.3, second one's also 25.3, we think. But we also know that there's about half a centimeter of error there, and there's half a centimeter on the first one, there's half a centimeter on the second one. So the way we look at this is we say to ourselves, well, okay, well, if I just split them apart and just say, okay, well, this one's A1, the first one is A1, then what's the maximum length that one could be? So the maximum length would be the average length plus that little bit of error, which is 0.5, which would give me a maximum length of 25.8 centimeters that it could be, okay? That's the total upper bound that it could be. Similarly, the same for the second one. It could be 25.8 centimeters long, potentially. That would give me a potential total length of 51.6 centimeters. If we then look at what's the minimum possible length that it could have, well, the minimum possible length of A1 is 25.3 minus that error, which is 0.5, and that would give me a minimum length of 24.8, and again, it would be the same for the second one. So that would also be 24.8. So then by putting the two together, the minimum length that it could be is 49.6 centimeters. So the way you would work out error is basically you would take the maximum length that it could be minus the minimum length that it could be, and you just split the difference between the two of them divided by 2. So you'd have 51.6 minus 49.6, divide the whole lot by 2, and that would give you 2 centimeters. So there's 2 centimeters. It could be 2 centimeters shorter, or it could be a little bit longer. So that means if we kind of split the difference halfway between the two, then we would get an error of plus or minus 1 centimeter either side. Okay. So you might ask yourself, is there an easier way or a quicker way to find the error when you're doing basic addition like this? And of course there is, and that's the whole purpose of this video. So when you're adding them, if you add, instead of working out the maximum and the minimum, if you add the two numbers, whatever they are, we've got 25.3 for the first one and the same again for the second one, then I get the average length that it probably is, okay? Probably is 50.6 centimeters in length. And then if I look at the error, well, if I add the error, okay, add the two errors, then I got 0.5 centimeters for the first one and 0.5 centimeters for the second one, and that gives me an error of plus or minus 1 centimeter. Okay. So how does that compare with our maximum minimum? So if we were to subtract the centimeter off of the 50.6 centimeters, then I'd have 49.6 centimeters, and that's the same as what I got for the minimum, which is here, okay? And if I was to add that centimeter onto the average, then I'd have 51.6, and that's the same as what I got when I took the two maximums, okay? So this is just kind of a little introductory video on this. All of the error rules that we will look at need to be grounded in a bit of reality, a little bit of common sense, okay? When we're adding them, we will add the errors. Okay, and I think this one is pretty easy to start off on. It's later on it gets a little